So far we've been solving equations. The solution to an equation is a single value. For example, if when I solve an equation, I get the answer x equals -1, then I can plot my answer. I can show the value of my answer on my number line, like this. This is the solution to an equation. The solution to an inequality can also be plotted on a number line. The solution to an inequality might look something like this. X is less than 2. That means that the answers that will work in the original inequality are all the numbers smaller than or to the left of 2 on the number line. So 1 will satisfy the inequality, -3 will satisfy it, 0, -10, -100, but 3 will not. In an equation, if -1 is the solution, then -1 satisfies the equation, makes it true. -2 will not. In an inequality, if x is less than 2 is the solution, then any number less than 2 will satisfy the inequality. Numbers greater than 2 will not. Not only that, but 2 itself will not, in this case, satisfy the inequality. 2, when you plug it in, will not give you a true statement. On the other hand, if your inequality symbol has a line under it, that means x is less than or equal to 2. The notation we use on the number line in this case is a closed circle at the value 2. Now what I'm saying is that x can be equal to 2 or x can be anything less than 2. X still cannot equal anything more than 2. The difference between the previous answer and this one is that in the previous answer, 2 was not included in all the possible values that satisfied the inequality. In this example, 2 is included. Either way, you can think of 2 as a kind of a cutoff point. It's the place that separates the values that will work from the values that won't. Whether or not the circle on the number line is colored in depends on whether or not you're working with an inequality that includes an or equal to statement. Here's another important idea when working with inequalities. If I start with a true statement, something like 2 is less than 10, and I add the same amount to both sides, let's say 1, then I get the statement 3, because I'm adding these two together, and 11, and notice that 3, the result here, is still less than 11, the result here. So no matter what I have on either side of an inequality statement, I can add the same amount, or subtract it, from both sides, and I'll still have a true statement. This is called the addition property for inequalities. All that really matters here is that you recognize that whether you're working with an equation or an inequality, you can add or subtract the same number from both sides without changing the truth of the statement. Here's our first example. Remember what we did when we had a problem that looked like this? Subtract 5 from both sides to give x equals 2. Since it turns out that the addition property works for inequalities just as well as for equations, I can substitute the symbol less than for the equal sign. This is still a true statement. If you take a number and add 5 to it, that number is less than 7. If I take 5 from both sides, I learned that the number that's my cutoff point for all the numbers I can add 5 to and still end up less than 7 That cutoff point is 2. I have to pick a number less than 2 for this to be true. Here's another example. If this had been an equal sign, I wouldn't have hesitated to say, just add 6 to both sides. Well, because of the addition property of inequalities, I can do just that, except that instead of dropping down the equal sign, I'm dropping down my inequality symbol. On the left-hand side, I have x minus 6 plus 6 is 0, so this is x plus 0, is greater than or equal to negative 3 plus 6. For x minus 6 to be greater than or equal to negative 3, x must be greater than or equal to positive 3. Graphing this, I find my cutoff point, positive 3, and draw a circle. Because I have the or equal to symbol, I can color that circle in. Otherwise, I'd leave it open. This time I want all the values of x that are greater than or bigger than 3. So I'm going to draw my arrow to the right of 3, where the numbers are bigger. This is the solution to the inequality. X minus 6 is greater than or equal to negative 3. The solution is x is greater than or equal to 3. The graph of the solution looks like this.